Today we are continuing to work with transformations. We're just doing something slightly different today in the sense of yesterday when we worked with transformations, we were focusing on transformations that happened to the parent function, that happened to the most basic function in the family. Versus today when we're working with transformations, we're going to take something that is not the parent function and we're going to move it up, down, left, right, flip it over, or make it bigger or smaller. So, now when we do it today, we are going to focus on linear and absolute value functions. Now, as I already mentioned, in this case, we are now going to be starting with a situation where we are given an original function to work with. So as we go through and do this, we're going to be given a function f or f of x, same idea. We're going to transform to the function g. At least for the sake of our notes, it's going to be f and g. On your homework, you might change around the letters. Just keep in mind on which one's the original and how it changes, and that's going to be easy because they're going to give you the original. Now, yesterday we talked about those transformations, but one of the things we didn't so much do is really kind of point out where technically they go in the function. I did in the sense of talking about things done to f of x versus things done directly to x, but I didn't kind of give you an overall format for the function. It's one of the things that they introduce in this section. If I am taking and changing f into g, then that means g of x is a function of f of x. So I can write g of x equal to something regarding to f of x. In this case, it's going to be a times f of b times x minus h plus k. Now that format looks a little bit terrible, and I'm aware of that. But really, it's kind of the same stuff as what we were doing yesterday with one tweak, really. We're going to be adding one thing today that we didn't do yesterday. When we're working with this, we're still dealing with our translations. We are moving up, down, left or right. Now, yesterday we talked about up being a situation where you have a function and now translations were adding or subtracting, was moving up, adding or subtracting. Adding, and did you have to add it directly to the x or to the overall function? The overall function. In this case, that's kind of like this k right here. When you're adding that number outside of the f of x, which in this case it's f of b times x minus h, but it's still, this was the function you started with a couple edits to it. Down was subtracting outside the function. So if you're subtracting some k value. Was left adding or subtracting? Left was adding. It's the one that's opposite of what you think it should be. And we did that directly to the x. So we did that inside the function. So that's where the h comes into play. You're going to be moving left if you're adding an h value, and you will move right if you are subtracting an h value. Really, this is the same stuff I told you yesterday. The only difference is I'm putting it in variable format. Reflections. How did we make something reflect? Or flip over? Put a negative in front of it, multiplied by a negative. So, in this case, it was either putting the negative in very front, so it has to deal with the a, or putting it directly in front of the x, which is the b. It flips over the x-axis if it is a negative a. And it flipped over the y-axis if it was a negative b. If you put the negative in front of an overall function, or if you put it just in front of the x. And then we have the dilations. The dilations essentially being that vertical stretch and shrink. Today, here's that thing that we're adding, that we're doing a little bit different. We are also going to introduce horizontal stretch and shrink today. We did a vertical stretch if we multiplied the function by a number. Was it bigger than 1 or between 0 and 1? Bigger than 1 for a vertical stretch. Vertical shrink or compression if you prefer, if a was between 0 and 1. In both of these cases, the factor will be equal to whatever number it is that you're multiplying by the overall function. This is where I made my mistake yesterday with vertical shrink. On vertical, the factor is directly that number. Today we're adding the horizontal stretch and shrink. Horizontal stretches and shrinks happen when you multiply something directly by the function x itself, the x in the function itself, I should say. So this is where that b comes in. Now I'm going to tell you right now, our book does not call it b. Our book, for some reason, calls it a. It decides that this is A, and this is A, and you need to figure out if it's horizontal or vertical based on its location. Now, technically, you do still need to know if it's vertical or horizontal based on its location. That's still a piece that I agree with the book on. I just find it harder to describe it by calling it A, but just don't be shocked if the book, for some reason, if you look at the book to try to make sense of something and it refers to it as A. It is a horizontal stretch, and I called it B if B is bigger than 1. And here is where we do reciprocals, is for horizontal. The factor is the reciprocal of B when you're dealing with horizontal stretches or shrinks. it has to be the reciprocal because of the fact that what happens vertically and horizontally essentially end up looking like opposites on a graph. If I stretch an absolute value graph vertically, instead of looking like the regular V, there's the regular one. If I stretch it vertically, it ends up looking like a skinny one. But if you thought about this horizontally, if you thought about what happened this way, it doesn't look like someone grabbed it and stretched it out horizontally. A vertical stretch looks like horizontally it got squished. Vertical and horizontal dilations end up working opposite of one another. A graph looking like this could be a vertical stretch, or it could be a horizontal shrink. That's where the reciprocal has to come into play, is that it tells you you're multiplying by this number and this is how it's messing with it. Now, if that piece didn't make sense to you, it's okay as to why these two are opposites. Just understand, if it is a horizontal stretch or a horizontal shrink, the factor itself is the reciprocal of the number that's actually being multiplied right here by the x. Okay. Today, the questions that you're going to see are going to ask you to write a function g whose graph represents the indicated transformations on the function f. From there, they're going to give you an f of x. And they're going to tell you what they want to happen to that function. Vertical shrink, factor of 1/2. Now, when you do this, essentially the challenging piece about this is making sure that you are putting whatever it is that it's telling you to do in the correct location of the function. That's where people get tripped up on this. So, when you do this, one of the things that can help you is to start by just simply taking that function, that 2x plus 3, put it in parentheses, and then as we're getting used to this, I'm then going to label, I'm going to put little arrows to where A would be, where B would be, where H would be, and where K would be. It's not a required thing that you do this. The required thing is that you know where they would go. So, when it comes to A, B, h, and k, this f of b times x minus h, that is your original function with some edits. So when I take my function, my 2x plus 3, in parentheses, that's essentially sitting right here. That means that the a gets multiplied in front of it, the k goes after those parentheses. So right here is where I would put any a values, while over here is where I would put any k values. Now I need to deal with where b and h would go. Now b and h are inside of that function. B goes directly in front of x, and h gets added inside the parentheses after the function. So a b would have to go right here, and an h goes at the end of the parentheses. Now again, you don't have to write that out, but it kind of gives you an idea of where things can go. Brandon, can we put the laptop away, please? In the future, ask before. Okay. So I identify kind of where those are, just to kind of get us going and get us used to this. Once you recognize exactly where those go, you don't have to write that out every single time. You just have to know where they go. Okay, from there, I look at this. Okay, I'm undergoing a vertical shrink. Vertical shrinks. Here and here. Have to deal with A. So that is going to be what I edit. It is a shrink. Well, that tells me it's between 0 and 1. Yeah, I knew that. The key thing is that it goes with A. So that means here's where I'm making my change. Since the factor is 1/2, I'm putting a 1/2 right there. It's the only thing I have to do on this one. It didn't mention anything related to B, H, or K. If it did, I would put those on there too. But it just wants me to put a 1/2 right here. I put those numbers in, the A, B, H, and K that it references, and then the last thing I do is I simplify. Can we simplify a 1/2 in front of a set of parentheses? What do? Distribute. What is 1/2 times 2x? X. What is 1/2 times a positive 3? Either 1.5 or 3/2. I don't care which way you prefer it. That's my g of x function. That's my edited function. Now, as we do more transformations to it, it gets a little more complicated, but for the most part, it's literally just making sure you get those numbers in the right spot and then simplify. All of the functions that you get today will be either linear or absolute value. Okay, got a few more examples? Oh, otherwise, that's all we're talking about today. Translated up 3 with a vertical stretch of factor 2. So, until I get used to it, I think of my original function being in parentheses, and then I remember A goes in front of the parentheses, B goes directly in front of the X, H goes at the end of the parentheses, and k goes after them. Again, you don't have to write that out, you just have to know where they go. I've got two transformations happening here. Up 3 and a vertical stretch. Moving up 3, is that A, B, H, or K? K. Moving up 3 means what's going to happen with K? Add that value. So I've got this x minus 5. I know I'm going to add a 3 to it because that's where the K goes. Vertical stretch of 2. Is that A, B, H, or K? Looking at the right one, vertical stretch. Vertical stretch, which letter? A, B, H, or K? A. Vertical stretch affects A. So I put a 2 in front of the parentheses because that's where A goes. And then I simplify. I'm going to simplify this down. What am I doing first? Distributing. 2 times x, 2 times 5. 2x minus 10 plus 3. Can I simplify further? Yes, I can combine like terms. 2x minus 7. That is g of x.
Isn't it plus 6? Oh, wait, no, it's not.
I was about to say, I'm like, I don't think I did it wrong. Okay. 2 more examples, then we're done. F of x is equal to negative absolute value of the quantity 2x plus 1 plus 3. I remind myself that the entire thing goes into parentheses. K goes out here, A goes here. Now, remember, B always goes in front of the x. If there's a number already in front of the x, like this case, and I think other cases, you essentially are putting it in front of that. Now, here's where I wish I had done a better job at saying this the first time around. K generally goes at the end of our original function. The original function was an absolute value, which means it needs to go here. When it's linear, it goes just at the end of the parentheses. When it is absolute value, it goes at the end of the absolute value. Okay, so we're reflecting it across the x-axis. Is that a change for A, or is that a change for B, H, or K? Reflect, x-axis, A is a negative. Okay, so I get a negative in front of my parentheses. Ooh, I should make sure I get all my other things taken care of before I go writing the entire thing. Okay, horizontal stretch factor of 2. Horizontal stretch, A, B, H, or K? B. Now, here's where horizontal stretch gets a little bit weird. Vertical stretch, the factor I gave you was the A value. Horizontal stretch or shrink, the factor I give you is not B, it is the reciprocal of B. If 2 is the reciprocal of B, what's that make B? 1/2. Reciprocals go both directions. If this is the reciprocal of B, that means the reciprocal of this is B. 1/2. And that needs to go, here's where I realized I shouldn't have started writing things out yet. Because I need to put a 1/2 right here. I need to put a 1/2 there, I needed to put the negative there. A 1/2 gets multiplied by what's already there, which was a 2x and a +1. And I got a +3. And I simplify what I can. When you're simplifying, you're technically working inside out. You're going through PEMDAS, which means the first thing you should simplify is the stuff in the absolute value, like the 1/2 times 2x. I get an x, still +1, and then I get a +3. I can simplify this further. Simplified forms never have parentheses. To deal with something in front of a parenthesis, I distribute it. When you're distributing, when there's an absolute value involved, you're distributing here. That takes care of this entire piece. You do not distribute it directly to the x or to the 1. You cannot multiply into absolute value symbols. Outside of absolute value symbol stuff stays outside. Inside stays inside. You also distribute it over here. Negative, negative. Positive. I'm left with the positive absolute value of x plus 1. Negative times the 3, minus 3. That is our g of x. The absolute value messes with people a little bit more because we want to multiply into them. You cannot multiply into absolute values. Final example. Absolute value of x plus 1 minus 1. Vertical stretch factor 2. And we are going to translate 3 right. Do my parentheses. A is there, H is, or K is there. Those ones people tend to do okay on. Where does B always go? In front of the x inside the function. Where does H go? Behind the one, but which one? That one or that one? In the absolute value. It has to go inside the actual function, the thing being done to all this stuff. Okay, vertical stretch factor 2. A, B, H, or K? Vertical stretch is an A piece. Do I do the reciprocals on a vertical stretch? No, when do I do the reciprocal? When it's horizontal stretches and shrinks. Okay, so I know there's a 2 that's going in front of my parentheses. Translate 3 to the right. A, B, H, or K? Right, 3 is H, specifically it's minus whatever that value is. So it's going to go here, which means this didn't get touched. Minus 3. Start inside the absolute value first. Yes, you can do both of these steps at once if you are okay with that. Inside the absolute value, I can combine like terms. I get an x minus 2 instead. How do I get rid of the parentheses? I times a 2 against the negative 1. That is one of the things I have to do with it. I get a minus 2 there. Do I multiply the 2 by the x and by the 2? Do I multiply it by the absolute value? Yes, I still have to essentially put it here as well. 2 absolute value of x minus 2. Lots of 2's on this one. And that is our g function. By the way, problems I did in the notes, harder than what's on the homework. On the homework, they only ask you to do one thing. I purposely wanted to give you problems where you did multiple things. So, we are on page 16. It is numbers 1 through 21, but those ones are the odds. 23 through 26. 27 through 33, also the odds. It looks like more problems than what it actually is.